Today we're going to be completing the square. If you remember yesterday, we had problems where we were solving using the square root method that were in this form where you had a parenthesis squared equals a number. And then we would simply just take the square root of both sides. Don't forget to take the plus or minus of this side and solve. So we would have the square to the left side just comes out of the root, x minus 3. The square to the right side is therefore plus or minus the square root of 15. Now if we wanted to do this in decimal form, which is sometimes asked to the nearest hundredth, or sometimes it'll ask, give me the answer in just simplified form, it's in simplified form right now. Because 3 and 5 are the only factors, that's not going to simplify anymore. I'd simply add 3 to both sides, and my answer would be 3 plus or minus the square root of 15. But if it wants it as a answer that is a decimal form, I need to do the square root of 15. Now you can guess that. Fairly easy. I mean, square root of 15 is just a little bit lower than the square root of 16. So you know it's like 3.8 or something like that, but I'm going to do it on my calculator just to check. And we get 3.87 to the nearest hundredth. So this value right here is 3.87. So now I have two answers. X is equal to 3 plus 3.87, 6.87, or 3 minus 3.87, that's negative 0.87. And those are my two answers. So this is what we did yesterday. So today we're going to start out with standard form. We're going to get a parenthesis squared so that we can square root both sides to solve this. I'll show you how we do that. We do that by what we call completing the square. Your goal is to get a perfect square trinomial over here. If you think about this value right here, x minus 3 squared, what would that be if I squared it out? Well, if you think about it, it means x minus 3 times x minus 3. If I square this out, x minus 3 squared is x minus 3 times x minus 3. Now I'm just going to distribute the x. What will that give me? X times x is x squared. X times negative 3 is negative 3x. Distribute the negative 3, negative 3x times x. Negative 3 times x is negative 3x. Negative 3 times negative 3 is plus 9. My answer would be x squared minus 6x plus 9. You'll notice that the first and the last term are perfect what? Squares. Okay, so if I have a perfect square trinomial, the first and last terms being perfect squares, the middle term being double the square root of that term, notice 6 is double 3, then I have a perfect square trinomial. I'll be able to put it in this form and solve using the square root method. So our goal is to what we call complete the square with that value. Now let me show you how you do that if you don't have a perfect square in that spot. So we're going to go over here, and this kind of explains it on I'm on page 127 in your blue workbook. This explains that what we will do to do that is we'll take x squared plus bx form. We'll take half of b, okay, so half of the number in front of the linear term, the non-squared term. We will then square that value and add it to both sides, okay? That will give me a perfect square trinomial, which then will let me take the square root of both sides and solve. So I'm going to walk you through that and show you why we need to be able to do this. Okay, the reason we needed to be able to do this is sometimes you end up with something that is not factorable, okay, as you have a trinomial. So for example, if I have x squared plus 5x plus 2, that is not factorable. There aren't two things that times to be 2 and add to be 5. So remember when we were doing this, I told you to just write unfactorable. It's because there could be solutions. They're just not rational solutions. They're irrational. They're square roots of something, right? So that's what we're doing here is we're going to actually be able to solve this equation by completing the square. So let me walk you through those steps. So the very first step is to get the quadratic and linear terms on one side of the equation and the constant on the other. So I'm just subtracting 2 to make that happen. So I subtract 2 to both sides. Once I'm there, I need to make sure that this first term, or the leading coefficient, is a 1. If it's not a 1, I'm going to have to divide it out. Now, I'm not going to make you do any of those today. In fact, I'm not going to make you do any of those ever for completing the square, because we're going to learn another way that's easier to do those. But if there is a coefficient of 1 on that square, completing the square is fairly simple. Okay, there's some things you have to do, but it's fairly simple. So first step, get the x squared term and the linear term, which is the x term. So this is the quadratic term and the linear term. On one side, make sure the coefficient on the quadratic term is 1, equals whatever it was. So in this case, it equals -2. Now, this is the completing the square portion. This is the important part. It's this taking half of the linear term and squaring it. Or linear term's coefficient, I should say. So I'm going to take half of 5. Do not write a decimal here. Do not turn this into a decimal. I can't stress that enough. Leave it as a fraction. Your life will be so much easier if you'll do these as fractions. Do not write this as a decimal. Okay? I'm going to square 5/2. It's easy to square a fraction. You just square the top number and you square the bottom number. I don't want a decimal. A decimal creates problems when you're squaring it. So just square the top and square the bottom. So 5 squared is 25, 2 squared is 4. This is the value I need to add to both sides of the equation. So on the left side, I have x squared plus 5x plus 25. I need to add plus 25 fourths. I need to add that 25 fourths to both sides of the equation. Well, I got -2 over here, and I'm trying to add 25 fourths. What am I going to need in order to add -2 to 25 fourths? I need a common denominator. So I'm timesing top and bottom by 4. 4 times -2 is -8. 4 times 1, there was a 1 down there. 4 times 1 is 4. Now I simply add the numerators, 25 minus 8. So think about being on a number line, 25 minus 8. That puts you at 17 over 4. That's my right side. My left side, I haven't changed. It's still x squared minus 5x plus 25 fourths. Where did the 25 fourths come from? Remember, we took half of 5 and squared it. Squaring 5 gives me 25. Squaring 2 gives me 4. So that's where the 25 fourths came from that I added to both sides. So the left side is now x squared plus 5x plus 25 fourths equals 17 fourths. Now a lot of kids are like, you just made this more complicated. You made the problem more complicated. Actually, I didn't though, because this is a perfect square trinomial. Okay, this is a perfect square trinomial. This has a perfect square root. So does this. So I take the square root of the first term, sine of the middle, square root of the last term. That square root of the last term will always be half the b value, if you notice. So square root of 25 is 5, square root of 4 is 2. Now, think about if I took 5/2 plus 5/2. What would I get? 10/2. What's 10/2? That's the 5. Okay, so that's why this is a perfect square trinomial. Double, or 2 of those, would make that middle term. Okay, but every time we take half of the middle term and square it, that is going to make a completed square where this is a perfect square root and this is a perfect square root, and it'll allow us to put it in one set of parentheses squared. From this point, I'm just doing the square root method, just like I did over here, where I took the square root of both sides and solved. I'm doing that same thing over here. So now I'm going to take x plus 5/2 squared, and I'm going to take the square root of both sides, where the other side was 17 fourths. Remember to take the plus or minus of this right side. Well, the square root of 17 isn't a perfect square, so I'm just going to write it as plus or minus square root of 17. But the square root of 4 is a perfect square. It's at 2. So the square root of 4 is 2. Square root of 17 isn't a perfect square, so I just leave it as a square root. And that equals x plus 5 halves. Now, how come the square went away? Well, when you take the square root of a square, it just comes out of the square. Square root of a square comes out of the square. So I went from x plus 5 halves squared. When I took the square root, it made just x plus 5 halves. Now I'm going to subtract 5 halves to both sides. So now I have x equals, notice you have a common denominator, both of them are 2's. So I'm going to write negative 5 plus or minus the square root of 17 over 2. If it wants the exact answer, this is the answer. If it wants exact answers, especially when you do Alex on Friday, this is the type of answers it wants if it wants exact answers. If it wants it rounded to the nearest hundredth, then I have to do that on my calculator, round it to the nearest hundredth, and then add it to 5 and subtract it from 5, and then divide by 2 to get my answer. So I'm going to go through that. So if I take the square root of 17, again, you know it's a little bit more than 4 because square root of 16 is 4. It's actually 4.12 when I punch it into my calculator. Then I'm going to take negative 5 plus 4.12, so negative 5 plus 4.12, and then divide by 2. So negative 5 plus 4.12 is negative 1.84, negative 0.84, something like that. 0.88, sorry. Negative 0.88, and then I'm going to divide it by 2. Half of negative 0.88 is negative 0.44. So that's how I got that answer. So this is one of my answers. Negative point, that's a decimal, 44. My other answer is negative 5 minus 4.12 over 2. So negative 5 minus 4.12 is negative 9.12 divided by 2. Negative 9.12 divided by 2 is negative 4.56. And that's my other answer. You will always get two answers. Remember, these represent the points that they cross the x-axis. They didn't come out perfect roots. I knew they wouldn't because I knew this didn't factor. Okay, so that's okay though. It still crosses the x-axis just at these decimal values. And that's how we find those decimal values. And that's why completing the square is so important. You will have equations that don't factor, and the only way to really solve that is with the quadratic formula, which is what we just did right there. Okay, I'm going to review a few more of these as we do the assignment. Now today's assignment is going to be a little bit shorter and a little bit easier because I only want you to do 1 through 15, okay, on the extra practice on 4.4. So I only want you to do 1 through 15 here, okay? Now 1 through 6 says complete the square for the expression, then factor the trinomial. So here I'm going to complete the square for the expression. So all I want to know is this is what's given. What should I add to this to make it a perfect square trinomial? So to do that, I just do the completing the square portion. I take half of the linear coefficient, half of 4. Half of 4 is 2. Square that value, 2 squared is 4, and add it to the equation. Notice x squared plus 4x plus 4, perfect square trinomial. Half of 4 doubled, 2 doubled, would be that 4. This is my answer. Okay. Same thing on this next one. It just seems like it will be harder because anytime it's odd, you're going to end up with a fraction. So notice that you're going to end up with a fraction on 5 and 6. Notice all these others are even coefficients on the x. So these will be pretty easy, the 12, the 14, the 18. But let's do one like 6. These are still not hard. You're just going to have a fraction for an answer. So I take half of 11. Do not change it to a decimal. Leave it as a fraction. Take half of 11, so 11 halves. That doesn't reduce. And then square it. So now I just square the top and square the bottom. So 11 squared is 121. 2 squared is 4. You're going to end up with a lot of 4s on the bottom because when you take half, there's going to be a 2 on the bottom. Okay, so that you're going to end up with some of these anytime this is odd, which is fine. So this 121 over 4 is what I need to add. In other words, the equation will be x squared plus 11x plus 121 over 4. Again, if you think about that, what's the square root of 121 over 4? Well, it's 11 halves. What's 11 halves? plus 11 halves. 11 plus 11 is 22 halves. What's 22 halves? 11x. You'll get that middle term. So this is the completed square trinomial. Notice perfect square, double the square root of that last term. Okay, now we're going to solve some equations. Now to solve the equation, it's very, very important that you end up with the x squared plus the bx on one side, and then on the other side you have the constant. So it's important to get it in this form with the quadratic and linear terms on the left and the constant term on the right. Okay, so we're going to walk through a few of these. I'm going to do 12 and 15 with you, and then I'm going to let you do the rest of them. So let's do 12 together. 12 is a little bit difficult because, again, the 15 is odd. 9 is going to be a little bit difficult. The 7 is odd, if you'll notice. 11, 8, fairly easy because those are not odd. Okay. Now, it already is in the correct form in that I have x squared minus 15x equals 18. So it's already in the right form, x squared plus bx equals c form. I just have to simply complete the square here. So I want to do that by taking half of the 15. Now a lot of kids will say, hey, wait, it's negative. I don't care. What happens when you square a negative? A negative times a negative will always be a what? Positive. What's a positive times a positive? Positive. Every time you're going to add, because it's positive, this value. Even if this value was negative, because a negative times a negative squared will be a positive. 15 squared is 225. 2 squared is 4. This is the value I want to add to both sides. So I write negative x squared minus 15x plus 25 fourths. Now, I got to add 25 fourths to the 18. 25 fourths plus 18. In order to do that, I got to have a common denominator. So I got to times 18 by 4 and times 1 by 4. Because it's 18 over 1, right? So now, 18 times 4 is 72. 1 times 4 is 4. 72 fourths plus 225 fourths is 297 fourths. That equals the left side. But the left side, I know, is a perfect square trinomial. So I take the square root of x squared, which is x, sine of the middle, minus, and the square root of the last term. Well, the square root of 225 fourths was right there. It's 15 halves. Notice that the negative actually staying there with it. Negative 15 halves squared. Now I need to take the square root of both sides to solve it. But remember, the right side I have to do plus or minus. The left side just comes out of the square. So the left side is just x minus 15 halves. The right side is plus or minus square root of 297 over 2. The 297 isn't a perfect square, so I just wrote it on top. But the square root of 4 is 2, so that is a perfect square. Now I add 15. Now again, if it wanted the exact answer, it would be 15 plus or minus the square root of 297 all over 2, because that's a common denominator. But in this case, it wants the decimal equivalent. So I got to do square root of 297 on my calculator. When I do that on my calculator, the square root of 297 is 17.23. So now I do 15 plus 17.23, that's like 32.23, divided by 2, which is 16.11, or 16.12 really, I guess, rounded. Okay, and then I'm going to do 15 minus 17.23, that's negative 2.23, divided by 2, and that's going to be negative 1.12 rounded. So those are our decimal rounded values to the nearest hundredth. And that's, notice what the instructions asked. Round to the nearest hundredth if necessary. Okay? Now I'm going to do number 15. 15 is easier. Why is 15 easier than 12? That's the difference. This one is odd. This one is even. The number in front of the x, the linear coefficient, determines whether you're going to have fractions or not. This one I'm not going to have fractions, so it's going to be a lot easier to solve. So if you think about this, I'm going to add 99 to the other side, and get it in the form x squared plus bx equals c. That's equaling the 99. I then want to take half of 2. Well, half of 2, see how come it's always easier when it's even? Half of an even will always be an integer. So half of 2 is 1. 1 squared is 1. I want to add 1 to both sides. Don't think 1 squared is 2. 1 squared is 1. So I want to add 1 to both sides. So I have x squared plus 2x plus 1, and then I have to add 1 to the 99. 99 plus 1 is 100. This is a perfect square trinomial. That's the whole reason we complete the square, is to get a perfect square trinomial on this side, so I can put it in one set of parentheses squared and then take the square root of both sides. So that's what I'm going to do next. I'm going to put it in one set of parentheses squared. Square root of x squared is x. Sign in the middle is plus. Square root of 1 is 1. So I have x plus 1 squared. How do I get rid of that square? Square root both sides. As I do that, I get rid of the square on this side, x plus 1. On the other side, I got to do plus or minus square root of 100. Well, square root of 100 is 10, so it's plus or minus 10. Now I need to subtract 1 to both sides. So x will equal, as I subtract 1, plus or minus 10 minus 1. So I've got to do positive 10 minus 1. 10 minus 1 is 9. And I've got to do negative 10 minus 1 more. Think about a number line. Negative 10 minus 1 more, you're at negative 11. Those are your two values. Okay? Now, don't forget to do the plus or minus, or you'll mess these up. You've got to do the plus or minus, even if it's a perfect square, positive 10 or negative 10, and then I would have to subtract 1 from that. So positive 10 minus 1 is the 9, negative 10 minus 1 is the negative 11. Okay? So I want you to do all of the rest of them on 1 through 15 on page 128. Okay? That's your assignment for today. Thanks.